Okay, here we have a challenging equilibrium problem. So let's start out with given information. So we have the mass of methane and mass of oxygen and volume and the temperature. So let me write down the given. And also I'm gonna show the Kelvin temperature by adding 273.2, and you should get 684.2 Kelvin. Next step, I'm gonna write down the chemical reaction according to the direction. It said methane reacts with oxygen to form gaseous carbon dioxide and water vapor. Or it said methane reacts with oxygen to form gaseous carbon monoxide and water vapor. So this is our equation 1. Our second equation is gonna be very similar, except we have carbon monoxide instead. Okay, next you should, as always, balance the equation. Looking at this, you're supposed to get, normally you don't want to start out with oxygen first, and thankfully we have the same number of carbon, so we can now divert our attention to hydrogen. We have 2 hydrogen here, and there are 4 hydrogen on the left, so I'm gonna multiply by 2. I'm gonna put 2 on the in front of water vapor. Then I have 4 oxygen on the right side, and I have to have 4 oxygen on the left side as well, so I'm gonna have 2 in front to balance it. And for our second equation, we should have, okay, same number of carbon, and I should have 2 in front of water again, because to make up the 4 hydrogen on both sides. And then we have 3 oxygen on the right side, so I must have 3 over 2 over here in front of oxygen. Next, I'm gonna write down, because our equation or our direction really specifies about what happens during the equilibrium. I'm gonna write down the ice chart for both equations. So looking at this, okay, I'm gonna first start out with the change. Okay, this C stands for change. I'm gonna say negative x, because we have 1 to 2 stoichiometric ratio. I have to have 2x, and in this case I have plus x because there's an implied 1 in front of carbon dioxide, and then I have plus 2x, okay, because our products start with 0 and they are gained during this process. And then our second equation, we have, since it's just separate equation, I'm going to use a different variable. I'm going to use y, so minus y and minus 3 over 2y, and plus y and plus 2y. Okay. And then the equilibrium is the addition of ice, the initial and the change. But as you see here, you're gonna get x when you add, you get 2x on this side. In other words, you are adding the column, and there's implied 0 for these guys as well. So we're supposed to get y and 2y. What else is given? They tell us at equilibrium the pressure of oxygen is at equilibrium. This is important. Our pressure of oxygen, the partial pressure, is 0.326. So I'm gonna write. Okay, but what you have to be careful is that it's a combination of this and that. When you add these together, you're gonna get 0.326 atm. Okay, and our pressure of water vapor happened to be 4.45. So here's the water vapor. When you add these up, so when you add them up, they add up to 4.45 atm. What else is given? That's pretty much it. Here's good news, since our question really involves with P. Okay, it said the pressure of carbon. It asks us the pressure of carbon monoxide and carbon dioxide at equilibrium. So this is ultimate goal we want to get. Not this. I'm sorry. This. So this is a PCO2 at equilibrium, and this is P. Not this. PCO. Okay. We have to find X and Y. So to restate our goal is find X and Y is our partial pressure at equilibrium for the carbon monoxide, and X is partial pressure of carbon dioxide. Okay. They want us to write this in ATM, or it looks, I guess it doesn't matter, but it's good to have ATM because we want to use the ideal gas law. Okay, thing is, we need more information. Where do we get that? Well, we need to use this information. This is crucial. Before that, let me first write down the equation we can form first. So you notice that when you add 2x and 2y, you get 4.45. I can write that equation as 2x plus 2y equals 4.45. Okay? But then we need more equation, because when you are given two variables for a single equation, there is no solution, or there are infinite number of solutions. So let's find out. Okay, using the oxygen here, okay, we are given the mass. Let's change this to mole. Okay, and then we're gonna use the ideal gas law. So let me start out with to find at the initial, we want to find the partial pressure. Okay, so we want to find these guys. Then we can add this and add that, and finally combine it with, or set that equal to 0.326. Then we have two equations, two unknown variables, and we can find the answer. But we have to do some work here. Okay, remember the everything is a gas in our both reaction, so we have to use the ideal gas law. PV equals nRT. So nRT over V if you look up, we are given the volume of 2.50 liter, and since we are given the 6.400, okay, now let me show you again. Okay, we are using this. We need to use this, this, and this to find the partial pressure of carbon dioxide. Okay. Oxygen has 32 grams per mole. Okay. So that's N. R is always 0.08206 in the ideal gas law equation, and temperature is 684.2 Kelvin, all over by 2.50 liter. You're supposed to get 4.4916 atm. Okay. Now you know that, in other words, if you combine these two, okay, I'm not going to redraw another line because it gets very messy, but you get the idea. You see that question mark? Okay, if you add them up, they happen to be 4.4916. We don't know how much are distributed to the first equation or the second equation. We don't know that, but we don't need it as well. So what we want to do is just combine everything that's in the oxygen and set that equal to the equilibrium partial pressure. So in other words, I have a 4.4916 minus 2x, okay, minus 2x and minus 3 over 2y equal 0.326 atm. Actually, you know what? I'm gonna write that. It's kind of messy, but when you add these to question mark, you're supposed to get 4.4916. Okay. So actually, we have two equations now. You have to kind of trim this. All right. You have to trim this. When you move this to the when you move this to left, and maybe you can move these guys to the right, you get you're gonna get 2x plus 3 over 2y equal 4.1656. Okay, I'm gonna keep extra digits. I'm gonna round up at the end, so don't worry too much about secret. So this is our second equation, with our first and second equation. Okay, so since we want to find x and y, this is very doable. What do? I say the simplest method is use elimination that you learned in algebra 2. Then I see that 2x and 2x cancel out, and this turned out to be, we're subtracting it, so we get y, half y, and then you subtract this, and you are supposed to get 0.2844. And when you look for y, you should get something around 0.5688. Okay. We define y to be the partial pressure of carbon monoxide. Okay, now we know x. Now we know y. We can find x, and I say the easiest equation is just plug it in. The 2x equals 2x plus 2y equals 4.45. Okay, just plug it in. when you look for X, you're supposed to get okay. I won't do all the algebra for you, but you're supposed to get 1.66 6562 ATM. Okay, so we have the answer, but we want to keep 3 sig fig. Why? Because if you go back to our question, the lowest sig fig we got was 3, and there wasn't really addition and subtraction. I will not count that our elimination method to be addition and subtraction, because that's just part of the way of doing this. So to keep 3 sig fig for both partial pressures, you just have to round up here, so you get 0.569 ATM, and you get 1.66 ATM. So our final answer at equilibrium, you get partial pressure of carbon monoxide to be 0.569 ATM, and then partial pressure of carbon dioxide to be 1.66 ATM. And that's our final answer.